Have you ever wondered why we can't just measure anything to any precision we want? Whether it's the length of a pencil or the current in a circuit, every instrument has a limit, and that limit is known as the least count. The least count of an instrument is simply the smallest measurement it can accurately record. Think of it as the instrument's resolution. Just like a camera has megapixels, a scale has its least count. So, when we say the least count of a meter scale is 1 millimeter, it means it cannot differentiate lengths smaller than that. This idea plays a critical role in chemistry, especially in experiments like titrations or thermometric readings, where accuracy matters. Let's now understand where this least count comes from. Every measuring instrument has a graduated scale. The value of the smallest division on that scale is the least count. For example, if a stopwatch has 10 divisions between 0 and 5 seconds, then each division represents 0.5 seconds, and that's the least count. This principle applies to all instruments from amateurs to burettes. It tells us what's the minimum change that our device can detect. It's like zooming in with a microscope. The smaller the least count, the finer the details we can observe in our measurements. Let's look at some examples of least count across instruments, both general and those used in a chemistry lab. A standard meter rule, it has a least count of zero point 0.1 centimeter or 1 millimeter. A typical laboratory stopwatch, zero point 0.5 seconds is the least time it can detect. An analog ammeter with 5 divisions between 0 and 1 ampere, that gives it a least count of zero point 0.2 amperes. And in chemistry labs, burettes used in titration often have least count of zero point 0.1 milliliter, allowing us to carefully track every drop of acid or base added. So, knowing the least count is like knowing your instrument's zoom level. But why does this all matter? In chemistry, especially during quantitative analysis, every decimal counts. A small error in measurement can lead to large deviations in molarity, concentration, or enthalpy values. When you're recording the volume of base needed to neutralize an acid, using a burette with a smaller least count gives more precise equivalence point readings. Even temperature measurements, like noting the boiling point of a liquid, rely on thermometers with fine least count, such as zero point 0.1 degrees Celsius, to avoid errors. So, choosing the right instrument with the right least count is a foundation of reliable chemistry lab work. Now comes the real world dilemma. Should we always go for instruments with the smallest least count? In theory, yes. Lower least count means better resolution. A digital Vernier caliper with a least count of 0.01 millimeters is far superior to a traditional scale in detecting micro differences. However, we must balance accuracy with factors like instrument cost, ease of use, and application requirement. For routine salt weighing, a scale with zero point 0.1 gram precision may be enough. But for analytical chemistry, we might need microbalances with least counts as low as zero point zero 0.01 milligrams. So remember, it's not just about having the sharpest tool, it's about using the right tool for the job. Let's quickly recap. Least count tells us the smallest value an instrument can measure. It reflects the instrument's accuracy and sensitivity. The smaller the least count, the more precise our measurements can be. But this precision must be chosen according to the demands of the experiment. In a chemistry lab, whether you're performing titration, calorimetry, or simple weighing, always check the least count of your instrument. It's your secret to scientific accuracy. Now you know, measurement isn't just about taking a reading, it's about understanding how precise that reading truly is.